Anyway, so I was given the nebulous title of application of industry detection systems. I wasn't quite sure what to do with it, so I took advantage of it to do what I felt like. So bear with me. So starting this out, I think from the outside looking in, I think the world of tributary pit tag arrays probably looks a little bit more chaotic than it is. I think one of the reasons for that is because biologists are sort of awesome people. I mean, we're innovative and we constantly push technology, and so we take multiple approaches to sort of reach the same endpoint. I think this presents opportunities and challenges. When we talk about moving towards standardization, I think we need to figure out how to do that in a way that doesn't stifle that ingenuity and creativity. So, for my opening slide, just maybe ruminate as I go through these slides about trying to apply standards across the diversity of stuff I'm going to discuss. And I'll try to go the right direction. Okay. So what I'm going to talk about is a subset of current applications of tributary pit tag arrays, certainly not exhaustive by any means. To talk about some innovations and continuing innovations and some challenges I think that we face when we talk about standardization of these things. So probably the application that most people are most familiar with is the use of tributary pit tag arrays to generate adult escapement estimates. So this slide is actually old and out of date, but it shows a number of locations in the Snake River Basin that we use to generate adult escapement estimates. So this starts with tagging of natural origin steelhead and spring summer chinook lower Granite Dam, and then subsequent detections of those upstream can be used to generate escapement estimates. Tissue scale samples collected from those individuals at the time of tagging allows those escapement estimates to be further decomposed by sex and age. Similar model was adopted for above Grease Rapids Dam, and that collaboration has produced a number of tools that I think continue to be useful, particularly this IPTDS, which essentially was our attempt to capture Rick Form's brain in computer form and summarize vast quantities of data. Anyway, moving on. Other applications. This is a WDFW product. Essentially, it's allowing them to harvest or manage harvest in real time. So basically, there are 8 or 12 or so harvest zones above Grease Rapids Dam, and the goal here was to, in real time, estimate the number of hatchery origin fish shown in red and natural origin fish in these fishery zones that you get to this point in time. So it's basically a fishery problem because the abundance of hatches greater than the abundance of natural origin fish could probably close your fishery here because your impacts on natural origin fish are going to. I'm not sure what I just did there. Okay. So I'm going to wordly butcher this. This is the nose first strike product. So these can be installed either permanently or temporarily. A little bit more cost effective in some ways than pipe antennas, but they have some limitations in terms of how closely you can operate these systems to one another. And so innovations aren't just technical, they're analytical as well. So what I'm showing here is the relationship between signal strength when a tag is detected and distance from the coil. And you can see there's almost a one-to-one relationship between signal strength and distance from the coil. So we developed a beta set of firmware for the IS 1001 and MTS, which will return these tag signal strength measurements so that essentially in real time we can estimate the detection range of those pit tag arrays. I don't know if you guys remember back to the last tag meeting, there was a lot of interest in generating real-time efficiency estimates and real-time read range estimates, so I think we're making some progress towards that end. So the reason we're here today is that this thing doesn't exist and everybody kind of wants it to. But there are some challenges that we face. So why is developing a set of standards so hard? And I would say that probably the biggest reason for that is that we have these systems in existence for a number of reasons. And Russell talked about this in his presentation. I would add research and development to this list as well. The point being that maybe you need to consider creating classes of pit tag arrays, and I think that having one set of standards that works across all of those classes probably isn't something that's realistic, but I think within classes it is. So I just wanted to give a couple of thoughts on how we can classify these things. One might be by purpose, so adult escapement, for example. That may be one way of skinning that cat. I think maybe a better way is to think whether you can generate detection probabilities with a single array or it's just part of a network. But I think that's one way of considering like a classification that might help towards developing standards. Other challenges I think we face, I mean, we have the TAGUS meetings once every 5 years, is that right? And that's just really not often enough. And so this meeting is a good step in the right direction. I think that really, I think we need better collaboration among researchers and industry, frankly. Because I think that sort of communication will help us continue to support analytical innovations and also the R&D support. I mean, there's a lot of equipment that's involved in doing R&D, and not everybody has access to it. But I think a little bit better communication, we find a lot of support in industry to move those innovations forward. Last challenge I want to bring up is really funding challenges. So, and Russell alluded to this. So we've all been in these situations before, right? So losing one pit tag array to a catastrophic event is probably something that we can all deal with in one way, shape, or form. But it's things like this that keep me awake at night. So, you know, it tends to be that we operate a lot of pit tag arrays in a small geographic area. And so oftentimes when there's inclement weather and rain on snow events, it affects that entire geographic area, which can lead to catastrophic loss of multiple pit tag arrays. The problem we run into is that there really isn't a good funding model for dealing with a situation like that. So we just argue that hopefully we get to the point of talking about either altering funding approaches or achieving economy of scale by grouping more projects together. So with that, I'll end. Last thing I want to say, and Russell alluded to this, we do have 2 reports that will be on the EPA website very shortly that could be a straw man for site installation and infrastructure selection, and also standard operations and maintenance that were developed for that pit tag array O&M project. So for those of you that are interested, I would be really interested in having your comments on that to make it a better document, a better approach. So anyway, look forward to an interesting conversation.